What are neurotransmitters in epilepsy? Have you ever wondered how our brain communicates and what happens when that communication goes awry? Neurotransmitters are the chemical messengers that neurons use to talk to each other in the brain. In the context of epilepsy, these neurotransmitters play a crucial role. The balance between excitatory and inhibitory neurotransmitters is vital because seizures occur when there is abnormal, excessive, and synchronized activity among neurons. The primary neurotransmitters involved in epilepsy are glutamate and gamma-aminobutyric acid, often known as GABA. Glutamate is the main excitatory neurotransmitter in the brain. It activates neurons, making them more likely to fire electrical signals. When glutamate activity is too high or not properly regulated, it can lead to overexcitation of neurons. This overexcitation is a key factor in initiating and spreading epileptic seizures. On the flip side, GABA is the main inhibitory neurotransmitter. It works to reduce neuronal excitability, making neurons less likely to fire. GABA operates through two main receptor types. GABA receptors allow chloride ions to enter neurons, leading to hyperpolarization and inhibition. GABA-B receptors modulate neurotransmitter releases through second messenger systems. If there is a deficiency or dysfunction in GABA signaling, it can reduce inhibition and facilitate seizure activity. The underlying mechanisms of epilepsy often involve an imbalance between the excitatory effects of glutamate and the inhibitory effects of GABA. This imbalance can result from altered levels of neurotransmitters, receptor dysfunction, or changes in ion channel activity that affect how neurotransmitters signal. Such disruptions can lead to the abnormal firing patterns seen during seizures. Other neurotransmitters also play roles in epilepsy, though they may not be as prominent. Acetylcholine, for example, can influence seizure susceptibility, especially in brain regions like the hippocampus and cortex. Additionally, monoamines such as dopamine, norepinephrine, serotonin, histamine, and melatonin can act as both neurotransmitters and hormones, affecting neuronal excitability and seizure thresholds. Nitric oxide is another signaling molecule that may influence cognitive functions and has been implicated in epileptic processes. Research has also shown that intracellular signaling pathways and proteins, like calcineurin and extracellular regulated kinases, can impact neurotransmitter receptor function and neuronal excitability during seizures. Understanding these neurotransmitter systems and their receptors is essential for developing effective treatments for epilepsy. Many antiepileptic drugs work by enhancing GABAergic inhibition or reducing glutamatergic excitation to restore balance and prevent seizures. In summary, neurotransmitters like glutamate and GABA are key players in regulating the excitatory and inhibitory signals in the brain. An imbalance between these neurotransmitters leads to the abnormal neuronal activity that underlies epileptic seizures. Targeting these systems is central to managing epilepsy effectively. If you or someone you know is affected by epilepsy, it is always best to consult with a healthcare professional for personalized advice and treatment options.